Hi guys, today we're learning about the derivative of logarithmic functions, and the syllabus dot points that this covers is calculate the derivative of the natural logarithmic function d on dx of ln x equals 1 on x, establish and use the formula d on dx of log base a x equals 1 over x ln a. So first what we're going to go through is the logarithm rules. So if y equals a to the power of x, then log base a of y equals x. If log of base a, x times y, occurs, then we have it equals to log base a of x plus log base a of y. We have if log base a of x divided by y, it equals log base a of x minus log base a of y. We have log base a of x to the power of n equals n times log base ax. That power of n has simply moved out the front. And then we have our change of base formula. So if we have log base a of x and we want a common natural base or base 10, we can have log of our base of x divided by log of our base of a. So what we're talking about today is the derivative of y equals ln x. So to find the derivative of a logarithmic function, we notice that the gradient of the function is always positive, but it is decreasing. So the derivative function of a logarithmic function is a hyperbola. So if y equals ln x, then we have dy over dx, the derivative equals 1 over x. Which is the formula for a hyperbola where x is greater than 0. If we have y equals ln of a function of fx, then we use the chain rule and we have dy over dx equals the derivative of the function divided by the function where fx is greater than 0. So let's have a look at an example. Our first example is to find the equation of the tangent to the curve y equals ln x at the point 7 ln 7. So when we're finding an equation of the tangent to the curve, we first need to find the gradient, and we find the gradient by differentiating. So y dash or dy dx is equal to, for y equals ln x, 1 over x. And then we substitute in our x value. In this case, it's 7, wherever we have an x, in order to get our gradient. And in this case, our gradient is 1 over 7. We're then going to substitute our gradient and our point of x1, y1, which in this case is the point 7 ln 7, into our point gradient formula of y minus y1 equals m bracket x minus x1. So when we substitute this in, we'll have y minus ln 7 equals our gradient of 1 over 7 bracket x minus our x1 point of 7. Whenever we have a fraction as our gradient, what we want to do is we want to get rid of this denominator first. So we're going to multiply both sides of our equation by 7. And in doing so, we have 7 bracket y minus ln 7 equals 1 bracket x minus 7. We are now just going to expand these brackets. So by multiplying this term out the front in, so we have 7y minus 7 ln 7 equals x minus 7. And then we're going to rewrite this in general form. So in general form is ax plus by plus c equals 0. So we want our x to be positive. So we'll have x minus 7y minus 7 plus our 7 ln 7 equals 0. So what we've done is brought everything on the left-hand side to the right-hand side. So to summarize, we minus 7y and we plus 7 ln 7 to both sides. And that is our equation of the tangent to the curve y equals ln x at the point 7 ln 7. Now we're going to have a go at differentiating, having to use the chain rule. So we have a function of, so we have ln of a function. So in our first example, we have ln x squared minus 4x plus 3. So in this case, we have ln of fx is what y equals, where our fx equals x squared minus 4x plus 3. So we need to differentiate fx. So the derivative of fx is 2x minus 4, and the derivative for our function of ln of fx, or ln of x squared minus 4x plus 3, is our derivative of our function divided by our function. So this will just equal our 2x minus 4 divided by our x squared minus 4x plus 3. So you simply just put your function on the denominator here, and then our derivative goes on the numerator here. For example B, we want to differentiate ln of x plus 2 divided by 4x minus 3. Now this is where our log laws come into play, because what we want to do first is we want to simplify. If I can spell. So simplify first using log laws, and for the sake of this example I'm going to write out what the log law is that we are using. So this is a division, so we have log of base a of x divided by y, which we just talked about is log of base a x minus log of base a y. So what we have is we have ln of x plus 2 divided by 4x minus 3 is equal to ln of x plus 2 minus ln of 4x minus 3. So now that we have this, what we want to do is we want to differentiate. So when we differentiate our logs, because we have functions here, we're going to differentiate to have f dash x divided by fx. But we have functions at each term. So what this will entail is we'll have y dash equals, so the derivative of our first function, x plus 2, is just 1, all divided by our original function, which is x plus 2, minus our derivative of our second function, so of ln 4x minus 3. So the derivative of 4x minus 3 is 4, divided by our original function of 4x minus 3. So now we just want to tidy this up. And so to tidy this up, we're going to multiply by the opposite denominator so that we have one whole denominator. So this will be 1 times our opposite denominator of 4x minus 3 minus 4 times our opposite denominator of x plus 2, all divided by our denominators multiplied together. So x plus 2 multiplied by 4x minus 3. And to clean this up, we have 4x minus 3 when we multiply 1 in, minus 4x minus 8, all divided by x plus 2 times 4x minus 3. And I've just run out a bit of room, so I'll just go over here. So we have y dash equals, if we just tidy up the top, the 4x's cancel out, so we are left with negative 11 divided by x plus 2 times 4x minus 3. We can leave the numerator at the denominator as is. We don't have to expand that out. So finally, we're just going to talk about the derivative of when we have log base a of x. And when we have this, we need to change the base first. We had to change the base in the previous question. With this one, we can differentiate logarithmic functions with a different base. So So, and in fact, what we're going to do is we're going to change the base. I just got ahead of myself. So if we have y equals log base ax, then the derivative is 1 over x ln a. So if we want to differentiate in our third example, y equals log base 5x, now you might be able to remember dy on dx equals 1 over x ln a. Or what you can do is you can change the base. Okay, so when we change the base, we need to use the formula of log base ax equals ln x over ln a. And so therefore, we'll have y equals log base 5x equals ln x over ln 5. And what we're going to do is we're going to bring the ln 5 out the front. So this will be equal to 1 over ln 5 times ln x. And the reason we do this is because 1 over ln 5 is a constant. So it will stay the same. So then what we're going to do is we're going to differentiate. So y dash, so the constant stays the same, so it will stay as 1 over ln 5 because it's multiplied to our ln x. And so all we do is we derive our ln x. So the derivative of ln x, you should know by now, is 1 over x. And so when we multiply these together, we have a numerator of 1 and a denominator of x ln 5, which proves how we differentiate when we don't have a normal base.